Hey guys, how are you? My name is Rehmani and today's topic is galaxy formation. Galaxy formation is a complex and fascinating process that began early in the history of the universe and continues to shape the cosmos today, the study of galaxy formation involves understanding how matter in the early universe clumped together to form the first galaxies, how these galaxies evolved over time and how they interact with their environments. Here's an overview of the key concepts involved in galaxy formation. After the Big Bang, the universe was filled with hot, dense plasma of particles. As the universe expand and cooled, this plasma eventually the first galaxy formed within this dark matter under gravity. This process LED extreme mobile of to understand how life might survive in harsh environments elsewhere in the universe. Examining what make a planet or moon capable of supporting life, including the presence of liquid water and essential of life for life. Water is a solvent that facilitates transit method, the most successful method of detecting exoplanets involves observing a star's brightness. If a planet passes in front or of transits the star from our point of view, it causes a slightly dip in the star's brightness. By measuring the dips, astronomers can infer the presence of a planet, its size, and its orbital periods. This technique measures changes in the star's spectrum caused by the gravitational pulls of an orbiting planet, which causes the stars of wobble. This method helps determine the planet mass and its orbit. So challenging due to the brightness of stars compared to planets, the universe expansions or scatter light. This makes it completely invisible to current instruments that detect light and other forms. The event horizon is defined by the escape velocity, which is the speed needed to break free from the gravitational pull of a massive object. For a hole, this speed exceeds the speed of light, which means that not even light can escape once it passes this boundary. Such child radius for a non-rotating, so practically symmetric non-rotating, especially Switzerland. The event horizon is a perfect sphere with a radius called Schwarzschild radius. This captured radius on the mass of hole. The more massive and hole, the larger event horizon. If the hole rotating in event horizon is not a simple sphere, but rather an oblated spheroid due to the hole. This types of black holes is known as scared hole. Horizon itself is not directly visible. Its effects can be observed as matter approaches the event horizons. It accelerates and beat up, emitting high energy radiation such as X-ray. This process called acceleration can be detected by telescope, allowing astronomers to infer the presence of hole. According to Einstein theory, the general relativity time slow down near a strong gravitational field as an object approaches the event horizon. Time dilation become extreme to a distance observer. It would appear that the object slows down and never actually crosses the event horizon, while from the perspective of the object itself, it would pass through the event horizon normally. The event horizon is in defining the hole's properties and behavior, but it also represents a fundamental limit. Light can escape once it passes this boundary, such what child radius 4 are non-rotating, so practically symmetric, non-rotating, especially Switzerland. The